In this video, we're going to start looking at sigma notation. And basically, all sigma notation is an application of what we've done in sequences and series so far. So all the rules that we've dealt with are going to be applied again here, but what you need to understand is that sigma notation is the shorthand version of when we want to write out a series. So if you had a normal series, let's say something like 3 plus 5 plus 7 plus 9, going on and on and on for 100 terms, you can imagine that that's quite a lot to write out. So instead what we can do is take something like that and write it in sigma notation. And so the notation itself looks something like this, where we've got this capital Greek letter S there, the sigma, and at the top we've got our ending value, and at the bottom we've got our starting value. Those two are what we call the index of the series, and I'll explain exactly how that works in a minute. Next to the sigma notation then, we've always got Tn. And you'll remember that Tn for an arithmetic series or an arithmetic sequence was the a plus n minus 1 times the difference. And for a geometric series or sequence, it was ar to the n minus 1. Or in some cases, when sigma notation does get a little bit tricky, is when you've got something that's unseen. And those can be difficult to work with, but hopefully in a video or two, we'll be able to tackle questions like that. So just to explain how this works exactly, if I gave you a question where we've got the sum, or the sigma, because the sigma notation just means sum, from n is equal to 1 to 100 of 2n plus 5. It basically means that this piece there is our Tn. And what we do, and we start by subbing in the starting value in for whatever letter you're using, because this might be n, sometimes it might be k or p. There's many different options, but whatever letter you're working with, you sub it in over there. So it's going to be 2 times 1 plus 5, and that whole piece together now forms T1. Then for the second term, you take the number that you've started with, which in this case is 1, and we add 1 to it. So the second term would be 2 times 2 plus 5. And then it would be 2 times 3 plus 5. And you would keep on going like that. And you can even simplify it in this case. It would be 2 plus 5 is 7, plus 4 plus 5, which is 9, 6 plus 5 is 11, etc., etc., up to 100 terms. And all of this together, if you refer back to the first few videos, represents your Sn. So you can often equate the sigma notation to the sum formula that you're working with, because it's simply just a shorthand way of writing out a series like that. So the steps that you'll generally follow when using sigma notation is firstly to write out the first 3 terms of your series as well as the last term. And to figure out the last term, all you do is take your end value on top and sub it into whatever letter that you're working with. And when we do an example, you'll see exactly what I mean by this. But it's the first 3 terms as well as the last term. Then your second step is to determine the kind of series you're working with. So is it arithmetic, is it geometric, or is there some other problem solving that you might have to do in the question? Then once you've done that, you go and simply use your Sn formulas. But the important extra step that comes in here when using your Sn formula is that the number of terms that you are summing up does not necessarily equal the end value at the top. Instead, there's another formula you've got to learn that will tell you the number of terms that you are summing up. And that is to take the top value, or the ending value, subtract it from the start value, or the bottom number, and you add 1 onto the end of it. That will give you the number of terms that you are summing up, or the value n that you're going to use in your formula. And then your last step is just to simplify. So those are generally the steps that we go through when working with sigma notation. Let's go and have a look at exactly how to apply that in an example. So let's have a look at our first example here of sigma notation. So it says to us, evaluate the following, where we've got the sum from I is equal to 0 to 99 of 2i minus 10. So the way that we always work with this is to start by writing out the first three terms as well as the last term. The way we find those first three terms is to take this bottom number and sub it into the letter that we've got there. So it's going to be 2 times 0 minus 10. That'll be our first term. Then to go to the second term, we need to increase that number that we started with by 1. So we would go then for the second term, plus, always a plus because it is a series, is 2 times 1 minus 10. And then for the third term, again, we put a plus there, and we increase that 1 that we just used there by another 1. So it would be 2 times 2 minus 10. And it's basically showing that as we go from one term to the next, the number that we're subbing in over there must always increase by 1. And that doesn't matter if it's arithmetic or geometric or whatever it may be. We always use that idea in sigma notation. Lastly, then, we want to work out our last term, which we see is where I will equal 99. So you're going to take that top value, substitute it in, so it's going to be 2 times 99 minus 10. And then we can just simplify that up a little bit, which looks like that. So there we have got the first three terms. We've got T1, T2, T3, as well as the last term that we want. We don't necessarily know if it's the 99th term, but it is the last term that we're dealing with. The next step then is to figure out what kind of series we're dealing with. And you can see that from one term to the next, if you go T2 minus T1, we get plus 2, and T3 minus T2 gives us plus 2 again. So this is clearly an arithmetic series that we're working with here. So because we know it's arithmetic, we know that we can take this whole piece over there and change it into Sn, because that's what it means. It means the sum of whatever we're dealing with. So in this case, we're going to change it to Sn, but before we can do that, we've got to work out how many terms are we actually summing up. So the way that we do that is to take the top number minus the bottom number on the sigma notation plus 1, which is going to be 99 minus 0 plus 1, because there's the 99, there's the 0, and then the plus 1 from our formula gives us 100. So it tells us in this case that we are summing for 100 terms. So the way that we work that out then is the sum of 100 using our normal formula for sum of arithmetic series is going to be 100 over 2. And we've got the last term, so we can use our a plus L variation if you wanted to. But that's going to be a, which is negative 10, plus the last term, which is 188. And when we simplify that, we're going to get 3,900, like so. And that would be what this entire thing evaluates to. So if you wanted to write it a little differently, you could say that the sum from I is equal to 0 to 99 of 2i minus 10 equals 3,900, like so. Let's have a look at another example then. In this example, we're going to look at writing a series in sigma notation. So it's almost like the reverse of what we were just dealing with in the previous example. And you can see here that we're given term 1, term 2, and term 3, as well as the last term in the sequence. It's given to us. So our second step then would actually be to figure out what type of series are we working with. And once you've tried subtracting T2 and T1 and then T3 and T2, you'll start to see that this is actually a geometric series where if we go T2 over T3, we get 1 over 3. And likewise again with T3 over T2, we get times 1 over 3. So it's a geometric series with a ratio of a third. And when we're looking at sigma notation, you'll remember that we wrote it like so. And in front of the sigma notation, we always had Tn over there. Now that Tn value is always going to be the general term that you've dealt with throughout this entire chapter for both arithmetic and geometric series. So for this particular case, because it's a geometric series, we know that the Tn is going to be AR to the n minus 1. So we can say then that the sum of this series from n is equal to 1, because that's just the natural starting point of any series we work with, will be A, which is 12 for your A value. Your R value is a third. Again, make sure it's in a bracket so that you never accidentally multiply those two together. And that is going to be to the power of n minus 1. So there's the starting point. However, we still need to figure out what that end value at the top is going to be there. And we can do that by using the last term that we're given. Because we know if we can figure out where that last term is or what position it's in, we'll be able to figure out how many terms we've added up here. So we can take then the fact that Tn is equal to 12 times a third to the power of n minus 1. And we can make it equal to 4 over 729. And then all we've got to do is solve for that position n. And so when we do that, we can divide both sides by 12. 1 over 2,187 is equal to a third to the power of n minus 1. We use a log to solve for n. So whenever we're dealing with a log, the exponent there, the n minus 1, will become the subject. The base of that exponent, which is a third, will stay the base in the log, so it will be log a third of whatever's left over, which is just 1 over 2187. And if we go and plug that in the calculator, we end up with n minus 1 is equal to 7. So therefore n is equaled to 8. But something that you need to be very careful of when dealing with sigma notation is that this n over here, or the position of the last term, is not necessarily the number of terms that you're adding together. So we still need to use that top minus bottom plus 1 formula. So we can see then that it's going to be the top number minus the bottom number plus 1 must equal this value there, 8. And so we get that the top number in this case is in fact 8. So just be very careful with it, that this top minus bottom plus 1 always needs to be used to check that you're adding up the correct number of terms. And that means that on the top there, we will have the number 8. The last example that we've got here is a little bit more tricky to deal with, but if we break it down, it does become a little bit easier. So I want you to start by focusing on one side of this expression at a time. So let's look at the left-hand side first. So we're told that the left-hand side is the sum from k is equal to m plus 1 to 2m of 2k minus 3. And you'll remember that whenever working with sigma notation, step number 1 was to write out the first 3 terms. So in this case, we take the number at the bottom, we sub it in for the letter that we're dealing with, which in this case you can see is k. So it's going to be 2 times m plus 1 minus 3. And this over here now is term 1. Then for term 2, we take whatever number we started with, which was m plus 1, and we've got to go up by 1. So that means in the next term, it's going to be 2m plus 2 minus 3. And that there is T2. And then for your third term, it'll be 2m plus 3 minus 3. And that, of course, is T3. And we have to do the last term as well. And the last term, we just take the top number and sub it into that letter k. The last term will be 2 times 2m minus 3. And then we could just go and neaten it up a little bit. And once we've done that, we'll get the following for the first 3 terms as well as the last term. Then we need to figure out the kind of series that we're dealing with. And hopefully you see that in every case going up there, it is adding 2 on to the series. So the fact that it's adding a constant difference, we know it's arithmetic. And we know the formula that has to be used when we're dealing with an arithmetic series. The thing though, again, if we want to go and use our arithmetic series formula, we need to start by figuring out the number of terms that we are adding. And to get that, we're going to take the top number, which is 2m, minus the bottom number, which is m plus 1 in that. When we simplify it, is going to be m, like so, because we've got that negative distributing in, so it's going to be 2m minus m, and minus 1 plus 1, which just gives us m. So that means that the sum of m terms is going to be m over 2. We can use our last term because it's given to us there. We can use our first term then as 2m minus 1 plus the last term as 4m minus 3. And that's going to be m over 2. And when we simplify the inside, it's going to be 6m minus 4. And when we distribute the m over 2 into the bracket, it's going to give us 3m squared minus 2m, like so. And what we already know is this entire piece over here, that entire Sn, is equal to 280. So if this here is our sum of m terms, we can go and equate that expression there to 280. So when we do that, we're going to get 3m squared minus 2m is 280. And we can see that that is a quadratic equation. So 3m squared minus 2m minus 280 equals 0. And for that, we can just go and use the quadratic equation, where our a value is 1, our b value is negative 2, and our c value is negative 280. And we get then that m is equal to 10, or m is equal to negative 28 over 3, which is obviously not applicable because m would have to be a whole number or a natural number. And so we've worked out then that our m value is equal to 10.